Hi, I am Ervine Flores. I'm doing the presentation group of the AC circuit.
Ready? Okay, here we go. Okay, so for the first part of the demonstration, we put together our simple circuit in multisim here. I used a 1000 and a 10,000 ohm resistors in series. And then we have our voltage source here. For this one, I did a 4 volt peak to peak and at 120 hertz, and the 4 volts equates to 1.414 voltage RMS. Okay, so we have all that set up. We have our oscilloscope here. I have it connected across the voltage source and across resistor 2, which we will obviously do here later. But for now, I will fire this up and show a couple of measurements to get us started. So we'll run it, and you can see here on the multimeter we get 1.41 volts across this source, and across resistor 2 we are getting 1.285 volts. And I'll bring up the oscilloscope here, and I will stop it so that we can do some measurements here. Okay, so I'll just do a couple of measurements just to demonstrate. We can see from peak to peak, it is 1, 2, 3, 4 boxes from peak to peak. Each box is 1 volt. So that would come out to 1, 2, 3, roughly 4 volts, which is indeed what our input is. And we can also measure the period if we want, going from this hill to this hill here, which is giving us roughly it's coming out to about, this says 8.447 milliseconds, roughly. Should be closer to 8, but we'll go with that, and that's going to give us a frequency of when I take the inverse of that, roughly 120.55. Okay, so we now have the same circuit set up here with our 1000 and our 10,000 ohm resistors on the breadboard, and we have it hooked up to the function generator set to 120 hertz. We carefully adjusted it to give us close to 1.41 volts RMS. That was about as close as we can get. And right now we have channel 1 measuring across the voltage source, and Rod is going to do a couple old school and new school measurements based on the output displayed on the oscilloscope now. Okay, so I will turn it over to Rod.
Okay. All right, so I'm doing the old school method of actually measuring the peak to peak value of the voltage on the sine curve here. So to do that, I take the position, take it all the way down to the base as much as I can. And then from that, you know that each division is 1 volt. So there's 1, 2, 3, 4 volts peak to peak. So that gives you
4 volts,
4 volts,
which is what our input was there.
Yeah, same as what's
So
on
that,
the,
yeah,
in the
that's
multi-
verified. So now we'll do new school.
So the new school,
Hit the measure first. Measure. Hit the measure. pick voltage, and then you're going to scroll down. Okay, that's it.
So that gives me the RMS.
Yeah. Did you hit it hard?
Yeah.
Come on.
There.
Okay.
So the VRMS is a 1.41, which coincides with the multi-sims guide, a 1.414.
I should do it frequency, I guess. Hit time. Push,
So the
push.
frequency.
Yeah. Push it again. There it is. And
So our frequency shows at 120.2 hertz, and we have
That's-
multi-sims at 120
that's consistent.
hertz.
Okay.
Consistent.
And that was a couple demonstrations across the voltage source. The next one we'll do is across resistor 2, which Ervine is going to happily demonstrate. Go.
Hey, I'm here. Now it's my turn. Right now we are doing the same as Rob, putting this down to the button.
This is for resistor 2,
Yeah.
by the way. Okay.
As you can see, I still find it here. Here it is, and you can see there are 4. So it will be 1 volt is 4 divided. So the peak to peak is 4, and the VR is over here. I'm going to do the VRMS for the second resistor. In here we have a value of 1286 voltage, but in here we have one box is 1 voltage, but look closely we have 1, 2, 3, and there's minus, so it will be like 3 quarters, so it will be 3.75. So then divided by 2, that gives us 0.875. Then multiplied by 0.707. That will give us a value close to the actual value, that is 1.325625. Then later on, here, go to voltage and find the value of the arm. That will give us 1.26, the one that it gives the 8, so
Close.
yeah, it's close. Then in here we're measuring the frequency. We know that it's got to give the one in the sample because it's the value of the frequency that we adjusted, but you can see that each box is like 8 decibels in this period.
Okay. All right, that concludes our presentation. Ervine, Rod, and Dennis signing off.